Hi everyone, this video is on exercise 13F, the challenge question. So this is the first question of the challenge, and in this video I'm going to do parts A, B, and C. So the nice thing about this question is that it helps us to get familiar with some properties of integrals, which are very useful. So we have this function f of x, which is x times 3 minus x, and we want to find the area of the finite region bounded by the x-axis and the curve with the following equations. So first, the first one is just a simple case. It's that when y is equal to f of x, which basically means that when y is equal to x times 3 minus x, um, we can first sketch this. So this curve. So we have a very simple quadratic, and the roots are 3 and 0. So here, and since this quadratic is negative, it's something like this. Well, yeah. Okay, so the region that is bounded between the curve and the x-axis is here. So in part A, we want to find the area of this region. We can also expand the bracket. We get 3x minus x squared. So first, the area is the integral of 3x minus x squared dx, which is between 0 and 3. So 3x integrates to 3 over 2 x squared, and then minus x squared integrates to a third x squared x cubed, and that is between 3 and 0. So we just substitute 3 and then take away 0 substituted, and finally the answer is equal to 9 over 2. So that's the area of the green region. Okay, now in part B, that's where the question starts getting interesting. So we want to find the area of y is equal to 2f of x. First of all, this is a transformation of f of x, which is just a stretch in the y axis basically. So 2f of x means that the y coordinates get doubled. So the curve is just going to be, and a stretch which is going to, at the peak, is going to increase. So that's just the meaning. And obviously, if we go on and sketch the curve, it's going to be very similar to this quadratic, but again, it's slightly just a stretch. So if we want to find the area when the equation is y is equal to 2f of x, let's see what happens. So we can write for part B, y is equal to 2 times f of x. And so let's write down the integral. We can write the integral of 2f of x dx, and again, the limits are the same, so it's between 0 and 3. And one of the properties of integral is that we can always take out the constant, so that goes out and becomes 2 times the integral of f of x dx between 3 and 0. And guess what? So we have already solved this integral in part A, which was the integral of f of x between 0 and 3. So obviously part A didn't have any constants, it was just this integration, right? So this is essentially f of x 3x minus x squared. So we have solved this and we got 9 over 2. So all we need to do is that we just substitute 9 over 2, because we know that the value of this integral. So it becomes 2 times 9 over 2, which is equal to 2. And that's simply the answer to part B. Of course, you could go and double basically f of x, which becomes 6x minus 2x squared, and then do the integration as usual, which you would get the same thing. But here, this is just a shorter way, and using also some properties of integrals. And part C is quite similar. It's just a generalization of part B. So we have y is equal to ax. A is just any generic constant in this case. So again, sorry, a times f of x. So we have this. Again, we can just write down the integral here. So that is between 0 and 3 of a f of x dx. And that simply means that a is a constant, so we can take this out and we'll have f of x dx. And again, we know that the integral of f of x between 0 and 3 in this case is 9/2. So it just becomes a, which is any constant, times 9/2, which means for any constant, if you have in this form, the area is going to be 9a/2. Right, so that's it for this video. I will do part D and E in another video.